So the topic is about software architecture and software quality, and before I go into the theme and explain what my topic is about, just want to do a bit of a quick survey. So this is geared for QA, so just show of hands, who is QA roles and everyone. Good. And software developers. Nice. Any architects here? Perfect. So we'll have some good discussion over that. And any of you working with a software architect in your organization, like anyone who has a job title of software architect in their organization? So that'll be some interesting conversations we should have. Perfect. So can everyone hear me okay? I mean, I haven't checked out the mic, but you're all fine. So the way this theme came about or the content of the slides was to see where software quality and software architecture come into play during a typical long project, right? And if you see in any typical life cycle, and this is just one, I'll show you for others in other types of models also, you have the initial large body of work or special types of people of the architects who come at the initial ideation and conception stage and try to draw the diagrams and architect the solution, and then they roll it out into development, and then the QA has the bulk of the work, and sometimes even to the end, the QA is the one that is working hard. And there is kind of a big divide between the beginning of the project, where architects are the major kind of contributors, and end of the project and the close of the project, where construction is the QA is the kind of the bulk of the work, and usually at that time you'll see the architects have moved on to other things, right? So there is a kind of a bit of a divide there, and
Dinesh, we may need this.
May need that? Okay. Should I?
That is okay. That is okay. That is for the video.
Okay. All right. So there was a kind of a divide between where architect roles play in the project and where the QA functions play at the end of the project. And I wanted to kind of bridge the gap there and see how QA folks can help architects and how architects can help QA kind of make projects successful and not have this wide gap between what the QA vision of what the project or the implementation should be, and the QA working with the code and the features saying that no, this is something different from what was originally thought about. So a little bit of definition for software architecture. In fact, if you see one of the CMU sites of what is the definition of software architecture, they have about 133 different definitions and still counting, and it's a community thing. So there isn't any well-established definition, and I think you can see why in a short while. But up to 2011, IEEE organization kind of defined architecture as this. It's just an organization of a system made of its parts, its relationships with each other, and the environment in which it works in, and some principles guiding its design and its evolution. So there are two themes here. One is the current structure and how we want to extend it. So there are some principles which say that this is how we have to extend it, and the architecture also defines that particular role. But that definition was not good enough. There were a lot of gaps in there, and I think many people kind of struggle to understand why these gaps are there. Why is this clean, precise definition not fitting what architecture actually does, right? And I think the realization came that you need many things to describe an architecture, and it's not one thing, there's not one diagram, it's not one document, it's not one piece that says this is the architecture of the system. It's many things all together. And so later on, the ISO 4/2010, they introduced many more concepts which says that, okay, these are all the concepts that you need to be aware of, and collectively that describes architecture more accurately. So I'll not take the time to talk about each of the concepts, that gets into pure architecture thing, but I'll talk a little bit about why these many things are required to kind of define an architecture. A lot about architecture is all about significant decisions. There's a term called architecturally significant use case or architecturally significant scenarios, which says that if any system had to support this particular use case, it defines or changes the definition of the system. Remove that use case, or change that particular use case, the entire system changes completely. So it's usually just one or two narrow particular things which define the existence of the system, why the system is built in a certain way, and why it should function in a certain way. And it talks about the decisions are made about organization of the system, about the environment it operates in, the structural elements, interfaces, behavior, and composition. And interfaces is something I want to point out more particularly. Interfaces is both between components with each other as well as with the environment. And often what we find is for any long-running systems that have been in existence for 3-4 years, the interfaces were defined to solve a certain problem. But 3-4 years later, the environment has changed, and it is at this precise interface that is broken down, that's where you realize, okay, we need to change the system. And that's where the need comes that, okay, I need to change the system precisely because the interface has changed, and okay, now how do I go about not repairing it, but extending it or augmenting it because the environment in which it is operating has changed. Not the complete environment, but parts of it, right? So it's not that we need to replace and rip out the entire system, but a portion of the system. And having this architecture in place kind of describes, okay, what is good and fixed and still working, and what needs to change, and if I change this, what is the impact, and how do I test it, how do I isolate it, and make sure that I don't have ripple effects and I'm kind of breaking apart everything. Architecture also includes many ITs. Sometimes you call them non-functional requirements. Not that they are not functioning, but it's hard to measure. These are things that are not specified formally. Things like usability, capacity planning, security, maintenance. These don't go tied directly into the features, but they are required for a well-functioning product. And I think this is one of the things where I kind of want to have a discussion with QA folks. I mean, have you encountered these non-functional requirements, and how do you test these things out, and how do you verify these kind of non-functional aspects? Have any suggestions? Like security, like how do you validate security of an application? It's not directly tied to a feature. It's in some cases actually a tax on the system, right? You pay a tax to make sure that the system is secure, but how do you validate it? Go ahead.
Our company hired a third party to actually go in and try.
Yeah. So you do have ethical hackers who can try to break into your system.
There's many tools that validate like common security issues.
Yeah.
Runs.
That's right.
Certainly there's best practices as well. I mean, for the database, you know not to give SA permission staff, so everybody must just not, code that way. I mean, you use best practices as a way of architecting quality into it from the beginning.
That's right.
You don't have to test as much as make sure you do it right to start with.
Yes. And I don't know, anyone working in banking or PCI compliant industries? So that's one of the key things, right? I mean, validating that your application is PCI compliant and credit card numbers are stored correctly, passwords are stored correctly is almost functional. You cannot even go live unless you meet those requirements, right? Sorry, you had a...
Actually, I think security is also a functional requirement as well.
Yeah.
And I've been testing security for my application 3-4 years earlier, and different type of security over there.
Yes. So that's a good point. In sense of security being a functional requirement in terms of logins and all of that and changing passwords, but sometimes what gets missed is permission leakage, right? You do some kind of an operation and suddenly the user gets elevated permissions. I mean, maybe unintended, but it's exploitable, and that's something that you have to have a different mode of thinking to see how to break a system in terms of security. I mean, leave aside the social engineering aspect of it, is just saying, okay, I have this application, how do I, SQL injection is a common thing, right? Where you just do put some SQL input and try to break the system and leak out the information. Yes,
There's also one more point around security. Companies or these products, they do add audit layer or audit table in the databases where anything that changes on the database side, they get recorded, and
Yep.
then you have weekly or say monthly audit who has logged in or who has not logged in, etc.
Right. But that also needs to be validated, right? So if you're doing a certain set of operations, part of the test is also to make sure that the audit logs have captured exactly the operations you were doing, and nothing got missed and nothing extra got added which you didn't do. So that's also sometimes a hard test to handle, right? That's on security. Reusability, that's always a holy grail for architects, and many architects I know, including myself, have stumbled upon this. Hey, I know if I do this pattern, it's reusable. But from a QA perspective, or like, how do you validate it's reusable?
User acceptance tests are generally a good way to do this. Actually get real users or the target audience who's going to be using the system to tell you if it's working the way they anticipate. And then that can be early conversations with product folks who know what the system is supposed to do from the aspect of the people who are going to do it
Right.
every day.
But usually for reusability is usually at the developer or the component system level, whereas other developers or other parts of the organization will use the systems you already built for their purpose,
Okay.
right? But, yeah, go ahead.
If it's a big client, usually you should ask clients business analysts. And if they present something will come with usability, we should always refer to the opinion backwards of the client's business analysts, because it was their job to assess all the functionality that the end users will use in its end product.
That's interesting, especially if the client is, you're a software company for hire building a solution for a client. Now, why should the client pay for you to build a reusable solution if he doesn't need it, right?
Yeah,
So-
and yeah, just as I said, if it's a big client, usually they will have a business analysis, and it will be their job to formulate the requirements.
Mm-hmm. Yes, but this is a non-functional requirement, right? So this is where the architects usually weigh in and hey, this thing is a common pattern, let me spend more time and make it reusable.
One thing you could look at is the ratio of components you have in your system versus the number of features.
Yep.
If you have one component for each feature, where you have zero reusability,
Yes.
versus the other extreme, where you're reusing the same component for everything.
Yeah.
Yeah,
So,
thanks.
true.
Would you like to elaborate on this? Sorry.
Sure, yeah. So one sense, it depends on the organization and where they're fitting in. So if you're a software development shop and kind of building turnkey custom solutions for vendors, and reusability needs to be literally restrained because you're not meeting the client's needs. Definitely you can reuse other the works that you already built and kind of delivering an efficient solution, definitely. But using the client to incur an extra cost because you're trying to build a reusable solution is probably doing a disservice to the client. So you have to be more prudent and pragmatic about it and kind of negotiate with your sales team to make sure that it is, probably, I think you might face this in Mobify where you're kind of customizing your mobile site across client to client, but you will see common patterns and definitely problems on the first client is, okay, I think this is going to be a common problem. How do I generalize it across other clients? But how to make sure that the client gets a solution in time? Yes?
I think that usability has two sides to it. One of them is the user interface side.
Yeah.
And in that case, some companies have specialists that are really good at designing the user interfaces.
Yeah.
And they know how to line those. The other side of it is kind of performance, capacity, security, maintainability, all of the other ones. And if you got those right, I think that's if you got the second side of usability right. If it performs well, it can scale, and it just doesn't get in the way.
That is true. Yeah, that's a good point. Anything else you want?
If you will go to maintainability,
Yes.
it depends whether you are considering maintainability for yourself or the client. When I was studying business analysis courses in BCAT, the best advice on maintainability was to turn bug fixes into a new product version.
Okay. That It depends, right? Ultimately, someone is paying the cost. So I think as software developers and even a QA, this thing you want to minimize that cost and.
The company will involve error in maintenance contract.
Mm-hmm.
It's probably makes sense to bundle bug fixes with the new product release that the client will be buying from you. And it will be written down in the contract.
Yes, that's how it, I mean, that's the logistics part of it, but from an architecture point of view, where the architecture gives guidance to the project on how to make it maintainable, so he is a little bit kind of predicting a little bit into the future of how should I be able to make the software easy to maintain, right?
I think it depends on who your client is. I mean, if you're someone like Optimus, who's writing code for customers and you're giving that to them, great, they're going to use it, they're going to pay for some amount of maintainability. That's one thing, but if you're the architect in an in-house system that you're going to have to maintain for the next 3 years,
Yeah.
that's a completely different value proposition to say, no, we need to engage a much higher degree of maintainability early on because we know we're going to be running this system for the next 3, 4, 5 years.
Yeah.
As opposed to we're doing a one-off solution for a customer who's paying us for a contract and then we're walking away from it.
Yeah, especially if the solution is evolving over time and there's a continuous addition of features over it, so you want to make sure the new features don't break the old features, or you're conscious of that something is changing and how do you make sure that what is not changing still functions correctly. So this is a little bit about where architecture and design kind of meet. I mean, architecture is design, but not all design, code design is architecture. And I can talk a little bit more about it, but does the audience want to just give a little bit of insight? Especially if you have been working with architects and developers who think themselves as designers, and how you see.
By design, we're talking about code design?
Usually. Yeah, not UI design, definitely.
That could be system design as well, I mean, which API talks to what, or what data flow, or what system you have.
Yeah.
That's certainly at the architectural level of design, but how the internals of a component might work, or how the internals of an API might work, probably not as much.
True. So anything usually internal, how the components are designed internally, what data structures are used internally, that's usually talked about as design. And architecture is pretty much any distributed system that comes in would be an architecture kind of a thing. For example, taking a crude one is like SQL Server. I mean, the authors of SQL Server at Microsoft, I mean, it's a complex product, and I'm sure internally there is an architect who kind of figures out how SQL Server works and interacts with all the parts of each other. But for an external architect who's consuming a SQL Server, it's just going to be a box on a diagram. SQL Server, that's it. It hides so much complexity behind it, but it has a very well-defined narrow interface which says that this is how exactly I'm going to call it, and it's going to do these things for it, and these are the other parts of the thing that's responsible for a thing. But so it's not about size. I mean, SQL Server is complex, and other databases, MongoDB or any other infrastructure like thing, they are also complex products. But how you use the interfaces and whether it's inward facing or external facing, that's kind of what defines where it is architecture and design. Sometimes architecture goes a little bit more into a design where it is a critical piece of the component, where either it has to be performant. I think the best example would be for trade exchanges, right, where they have to have near real-time responses of transactions, and then your transaction, which in a SQL Server is taken for granted, needs to be highly optimized in a trading exchange kind of a place, right? Because it just, the scale and everything is just out of whack. Architecture is a little bit, tends to be a bit abstract, whereas design is more of a concrete implementation of this is how the code actually runs. The architecture says it has to meet these functional and non-functional requirements, and then he leaves it to the developer to kind of have the best implementation for it.
Sorry.
Go ahead. Yes.
Point. I mean, come and start design or architect thinking about the system, wouldn't be the role of architecture to decide, am I going to use SQL, am I going to use MongoDB, do I want to distribute the data horizontally, do I want to do it vertically, what is the performance, just since you brought up the topic of database,
Yep.
picking what database, what data model, how distributed, vertical, horizontal, performance, transaction perception, wouldn't that be all the responsibility of the architect?
Yes, that would all be responsible of the architect, that is correct, at the database level. Where the designer comes in terms of the table structures, but it becomes a bit more internal, at least at the database level, right? The table structures and whether things should be implemented as a trigger or as a stored proc or something just in the middle tier. So that's where it kind of gets blurred between where the architect comes in and how much detail does the architect have to get into to prescribe the solution.
That's the thing, that's exactly what it is.
Yeah.
It's pretty blurry because the architects have to know the internal database in order to decide,
Yes.
is this database going to satisfy the performance issues that I want?
That's right.
Is he then going to decide, or I use the SQL, what's the performance of the SQL locally versus running it in the cloud?
Yeah.
Azure environment. So
That's right. So that's where the architects take concerns beyond just the technology solution. And I have a slide that talks a little bit. But it goes a little bit beyond it's not just about solving the problem. He has to take into other concerns also, including cost, including people skills, maintainability skills, operational skills. I mean, there's no point getting a MongoDB if the operations person does not know how to troubleshoot a MongoDB database. Or if there's only one person who knows about MongoDB and that person goes on vacation, well, now you have a problem. You have a different problem, right? So that's where the architect looks at the organization's strengths and figures out what is the right solution here. And as a long-term strategy also, if he says that, okay, we need to shift towards a NoSQL database, how do we make that shift? Not because he likes it, but this is how we need to go towards it, and what is the strategy for getting towards that?
One terminology that I recently heard, which I thought was really good, is you said non-functional, and you said, oh, it's not really named well. The terminology I've heard is cross-functional.
Right.
So it's actually orthogonal to your design. So there are things that do matter where it's not simply I do architecture and then we have a barrier and then design continues. It's rather they're orthogonal to each other, and architecture affects all different design. And one way to think about that is think of the dysfunction that occurs if you try to just start designing in the absence of any architectural alignment.
Yep.
And then see the dysfunctions that occur and the local optimizations that occur, and how much do you care about that, right? If you don't care, then if your space is to go and do a consulting gig with some customer, maybe you don't care enough that it's not worth
That's right.
spend of it. But,
Yeah, that's a good point to use that, treat it as, because I think the non-functional just almost says, well, I don't care, or it's something that can be discarded or paid attention to later. But I think cross-functional, I think probably would also relate more to the developers, where you have this aspect-oriented programming where you can just attach attributes to various methods and common operations gets implemented for all of the methods. Like you can just say this method is concurrent, or this is a test fixture. You just attach attributes to the methods, right? Those, I think that would probably relate well to the developers in terms of cross-function. Little bit of a segue into the agile world, and I think there's a bit of a tension between whether architects are needed in an agile world or not, and want to talk a little bit about that. How many are in the follow agile practices? Good, almost all of you, perfect. And how many of you feel lack of documentation, kind of saying that, okay, there is a tension here where Agile says if you emphasize working software over documentation, and you see that it swings too much towards working software and not producing enough documentation to help you. Do you feel that it's not right? And I think many people miss the point. I mean, these are all important points, individuals over processes and all of that. But there is a rider over here which says that while there is value of the items on the right, which is kind of seen as traditional, there is also value on the left. But it says that there is value here. It is non-zero. And I've seen many teams where they say, well, let's take working software, let's drop the documentation. Or let's drop the plans, but just we'll get there when we get there, we release when we are ready, right? Go ahead.
So if you see most iOS apps, most mobile apps,
Yeah.
they have documentation in our software.
Yeah. So, yep, go ahead.
Moreover, the new clients, it's really your company is building the documentation if you are going to maintain the software.
Yes. So it's not just about maintenance also, right? Sometimes architecture really shines when you have complex products. And mobile devices, probably they have this thing where, well, the space is small, the code is small, so I don't need that much documentation. Probably they're right, there is not that much code to navigate through. But the moment you have a system that requires multiple servers and different processes doing different things, and they all need to talk and orchestrate with each other, you need an architect to just design, okay, what does the plan look like? What is my current state? What is my desired state? Or if I'm building something new, what does the final end state look like, right? And
are you really doing agile then if you have that sort of set out plan? Because you can't really adapt to any changes that come along, which is what agile is all about, right?
Yep.
So, I mean, if you're following an architected plan, it really means that you're mostly waterfall and you're going to be blocked by a lot of things.
yeah, and no, that's a very valid point. And if you looking at sorry, just one second. So if you're looking at Greenfield development, which is you don't have any existing legacy systems to deal with. You're just starting from scratch, right? You don't have any constraints and in terms of existing customers, existing systems, and you're just building up applications from scratch. Then yes, architecture is an Yagni, you don't need it now, or it's a big design upfront where you're saying that no, let's get some working software into the hands of the customers and see that. Definitely architecture needs should be reduced for Greenfield development, and most of the time the architecture work is really between trying to anticipate versus trying to adapt. If you can adapt, then you don't need to anticipate everything. But at some point, if you know that this is what you need to, you have to be prepared for it. Otherwise, you're going to be in a constant state of refactoring. And if you're in that constant state of refactoring, you're not building up a whole cohesive system, right? It is literally becomes a band-aid. And at some point, you're going to say, okay, you're so far off, whatever thing is not working, you may need to look at massive rewrites. And that also costs a bit. So it is balanced, right? It depends on the culture of the organization, the people, the skills of how much forward planning I can do, not too far ahead, but not just literally next week alone. Right.
I think a concept that helps a lot to track that is there's the term of technical debt. You can take that to the architectural level with architectural debt. Know that when you're ideally in your architecture, you could have a better solution, and then know when to take that debt so that you can adapt or anticipate.
Yes. I don't have anything here for technical debt, probably should put it in. But if you heard of Philip Cruch, and I used some of his material in this thing, but he has a good talk on technical debt, and he has this quadrant of features and kind of maintainability. And technical debt is anything which you say that, okay, we need to do a hack here to kind of get the solution out faster, right? So now the solution works and it meets the needs, but you still have that hack in place and you want to know whether you want to fix it or not. So there is a difference between technical debt versus a refactoring, which is to improve the business value. A technical debt is almost, there is no perceived business value. It is more to make things easier on the developer side of things often, but it's hard to draw out the business value and communicate that out. And sometimes that's where the agile thing, and even from the quality people, is to say that yes, we need to fix this technical debt, but let's change the conversation in terms of what is the business value that is going to be derived. Is it more of efficiency? Can we develop faster? I have these test cases that I don't have to run anymore, or few other things, right? Somewhere you have to kind of get that value out of why you want to incorporate this technical debt. And somewhere there will be a median which says that, okay, I don't want to do zero technical debt. I don't want to spend the next 5 sprints just focusing on technical debt, but somewhere in between you can say that, okay, maybe I can take a sprint or two to just to focus on this, and I can communicate the value of the work that I'm doing.
So you mentioned about a few slides back about how an architect's job is to determine the products that you're going to use best. So you said like you wouldn't use MongoDB if you only have one person in the company that knows it. But if that's the best solution going forward, why would you toss that out and then have yourself with either a lesser performing product and then just piling on hacks to make perceived performance
yeah. So okay, I wouldn't call it tossing it out, but it does need, architecture is all about communication, right? So you need to communicate why this particular solution is the best fit for the solution and what else is needed to support the solution. And you have to get buy-in. If the architect cannot make his case that I need to go hire more developers who have the skill, at least for some redundancy, or a training program in place, and hence reduce my velocity and all of that, then the architect has failed at his job, right? So it's not that, or it just may be pragmatic. The CEO has said no more hiring, tuition is freeze, and okay, now we have a very hard constraint to do, and we still try to make a solution in spite of that. Yes.
I think that's kind of a common situation too, where you can propose the best technical solution for the problem that you're given, and somebody says, that's wonderful, but I don't have that $4 million. So what can you give me for $3 million value?
Yeah.
And that happens a lot. The other thing too is, when we were talking about databases earlier, it's not just about the architect saying, I want a SQL Server or I want this. It's about, I want the database that performs to these specs. Now make a technical decision on which way to go. As long as it conforms to this requirement, I think we've got our architectural need down. The company that you're working with will kind of give you that feedback. As Dinesh was saying, we're talking about communication with the customer. That's important because they might say, we're a SQL shop. That's what we do. That's what we're comfortable with. That's what we know. Will it work in the solution? If not, then we're going to talk about something different.
Yeah. So good points in the sense of it's a selling job and trying to find the best solution and a lot of constraints. And I have a slide which says that an architect's job is to make a suboptimal decision with incomplete information. And really that is a suboptimal decision being made given the information he has at the time, right? How many of you are following this kind of a model, Agile or Agile Fall, which is where the initial stages are very strictly waterfall, and then the dev team gets it, and then they have the sprint or a scrum model of iterations, and then once it kind of comes out of it, the QA is almost like a waterfall, and then there is a maintenance cycle. It happens, right? That's the reality also, and while I think we software developers are incredibly lucky that, right, we change is what we kind of excel in. Everything changes and we just know how to handle it. But a lot of other before and after, they need a little bit of constancy and predictability, and so they're still mode of let me do this thing first, let me get it first, then I hand it over to you. So there is some organizations are like that, and sometimes you have to work within those organizations too. And this is where architecture also helps. And a good architect who is working with an agile team can kind of strike a right balance of not too much planning, but just enough planning to cost a solution out and at least say, this is how I think your solution will look like if you want to do the full meal. And this is probably the minimum we need to do to make sure we can go to market faster and at least prove our concepts out. And then we can refine it. So it's not too much locked in decision, but I have enough plan of how to get there, right?
So is it part of an architect's role, modern architect's role, to, I guess, work with QA and say, well, not just here's what the architecture is, but here is how it's testable?
Yep.
You know what I mean? Is that part of the role, or is it a matter of just being a collaborator with QA?
It's a collaborator with QA, but also to communicate how the different pieces interrelate. Because architecture is a top-down design, but when you're testing, you want to do bottom-up. And it helps by looking at the big picture that, okay, this is the piece that I'm testing and this is how it fits into the whole, and does it really fit in, and when it comes time to integrate, I know the things will work with each other, or if something is broken, I know, looking at the thing, what part of my system is broken down, right? And I think it's the goal of the architecture through diagrams and everything to communicate what does the big picture look like. So it's not just about testing, it's making aware of the constraints and the interfaces of the system so that the QA can make better decisions about if something changes, what are the impacts that can happen.
Sure. So say we go back to the cross-functional requirements.
Yep.
Those, maintainability, reliability, security, all those things. How do you get metrics around that? Generally, is that an architect's kind of thing nowadays to really figure out, like, well, here's ways to get metrics or test cases around, the security or whatever?
Mm-hmm.
Or is that something that QA as a profession knows and architect works with them to just make it happen either at the beginning or in the middle of the cycle?
Yeah, so usually it will be good if you can have an architect work with the QA. In terms of metrics, some of these are very subjective. They're not easily convertible into numbers. So it is subjective, so it might literally be a checklist of things that we just need to create to say that, okay, if we do these, we think at least it is secure and it is usable.
With our experience, whatever.
With our experience, yeah. And we also have the scaled agile framework, which I think is where more agile businesses have recognized that architecture needs to be a part of their business planning. So it's just not about business features and all features only all the time. There is architectural epics needed where the organization says, okay, this is how my end state should be, or at least our current end state for the plan, and this is how we need to get there, and either for strategic reasons or to reduce cost, or say that, okay, if I need to build this kind of a product in 2 years now, I have to start planning and building some things today. And those are all be architectural epics that needs to be sliced into your regular feature delivery, right? So that kind of gets recognized at the executive level that they need to invest in these kind of architectural epics where the return is at least 1 year or so far in the future. It's not an immediate value that you're getting out of it.
Sorry, just one more thing about the safety, because going back to what you were asking about, there's something a little bit hidden here, but it says architectural runway, and it kind of bounces along there.
Yeah.
That kind of seems like anything. It's like having just enough, and it's like you're talking about the balance of like how much is enough ahead of time versus too much.
Yeah, and most of these reasonable good, at least do a quarter's work of planning. So that's a little bit far ahead enough to say that, okay, this is how we want to get there. There might be a blueprint which says that in 2 years, this is where we want to be. But we are just fleshing out the details at least for a quarter. And then we work towards that quarter with mix of architecture, epics, as well as feature delivery. And then replan again and look at what we did, what we accomplished. Has the market situation changed? Do we need to adapt? So you have this runway, literally a runway of at least a quarter or a half year kind of a thing where you look forward and get some visibility into it. So it's just striking a balance between sprint by sprint work, which is like 2 months to 2 weeks to 1 month kind of horizon, versus something more longer term where you need to make some of these larger investments upfront. And of course, there's the rational unified model, which talks about iterations, but there are phased iterations where you have the initial set of iterations around inception, where you create the ideas, and then go on to elaboration, construction, and testing. But once again, the architect's roles play very heavily here, and often I find QA brought in at this stage, and the architect has moved on. And there needs to be some handover and communication taking place. And of course, it will be good if the architects can stay on till the construction stage and see the results of what he has perceived and what is finally shaped up. And the QA can come in the earlier stages and influence and kind of get these metrics in place and checklists in place, and what are these cross-functional requirements, and how do I actually measure those, or how do I test for those things right up front. So in a sense, so you need architects and architecture where you have complex projects. I mean, there is no kind of avoiding it. And almost many of the systems we are building are complex projects where you have multiple systems and the long-lived systems where 5-year-old, 6-year, 10-year-old systems that just keep running and chugging away and still doing work, and no one wants to touch them. People who worked on them have gone away, and you still need to find out how to enhance them and maintain them, right? Integration with existing systems. As I said, it's very few companies that have greenfield development where they don't have to work with existing things, but many established companies, they have their own back office systems, they have their own established BI system, they have their own business processes in place, and the requirement is to work with those and build something new. So you do still need to integrate with them, and they come with their own baggage that you need to be aware of. And enterprise level architecture, where you're talking about the business level of, in terms of how does the business operate and what is the structure of the organization will look like in terms of how it delivers its services. And that is also an architect's role in terms of, I think we'll talk about it in the next slide, in terms of how the IT software and hardware looks and what are all the projects and how do each of them help each other and contribute to the organization's goals, right? And that needs some planning at the enterprise level also. We also have solutions architecture, which is probably at a smaller space where you're just talking about a product or a component and then just describing the architecture of that particular subsystem in place. Just different types of architects. So to quickly summarize, it is architecture is about making suboptimal decisions. As I said, you have incomplete information. You don't have the time to collect the information, but someone needs to make a decision. So usually the architects are leaders and who have to make a decision. It might be a wrong decision, but they won't know it until they actually go down to implement it, and then they can figure out how to correct it. Or they know if it is suboptimal, how to kind of mitigate it or kind of risk avoidance and highlight it as risk. They're also the ones who decide the interfaces and the behaviors, and these are particularly important because this is what allows parallel development. Someone decides, okay, we need these two components to talk to each other, but neither component exists, but I cannot have a staggered or a sequential delivery. First I deliver A, then I deliver B, and then I realize that I can't put the two of them together. So someone has to decide this is how the interface is. This is how components A and B will talk to each other. And then at least we can do work in parallel, do some early integration, and then kind of keep refining upon it, rather than build one, wait, and build the other, and then wait, and try to get both teams kind of in sync. Sure.
Certainly at that interface and behavior level, that's where I've seen the ability of QA to interact quite well with architecture. It's knowing that there's going to be an interface between two components that can help you design the tests around it, particularly when these are subsystems well below the front end, right? You can write automation against that communication layer. And that's where having an architect sort of on your side, where you can have that conversation as early as possible is good. That's one way to get QA more front-loaded to the system and use an architectural resource or a diagram, preferably something.
Yeah. All right. So the language of architects is diagrams. I mean, I don't think any architect can convey what he's trying to convey without a diagram. And in my experience, I've seen everything from simple diagrams to something that just took the entire wall of this room and needed a big plotter and what I call and so on. Unfortunately, there is no one diagram can convey the architecture of a system. And if anyone points to you, take one diagram and say, this is the architecture of the system, they are wrong. And the best example I can give is something of a human body, right? A human body is a complex mechanism, right? It's amazing and it does a lot of things, and there's a lot of things put together. But if you're trying to learn, if you're trying to understand, you're trying to fix it, you don't want this big picture. You want pieces, right? You have the skeletal structure or depending on what you're focusing on. So there is a context there which says that, okay, I'm going to look at this particular context and I'm going to exclude everything else, right? And and you cannot just do that for one thing. You have to draw another diagram which says that I'm going to look at a different context, and because I'm going to emphasize certain things, right? And that's what most of the software architecture diagrams are about. You need multiple diagrams to convey the information, and together that's what describes the entire system. And that's probably what the challenge came with the original definitions of what a software architecture is. They were all pointing out, no, it is a class diagram, no, it's an interaction diagram, or it is kind of handling all of these non-functional things. But no one thing describes it accurately. So you need all of these things together to describe any architecture system. So Philip Cruikshank, who lives in UBC actually, so he's kind of a pretty famous architect and written a few papers, and he's kind of done a study of all the different types of diagrams, and then he wrote up this paper in about 2010 about the 4+1 view model. And essentially he says that to describe any kind of an architecture of a system, you need at least 4 types of diagrams. Types, you'll need more diagrams than that. But he says that pretty much you need the logical view, which is your static view of your system. You can think of it as in terms of ER diagrams or class diagrams, which just describe the entities and the relationships between them. It is the static view, it is a permanent view. Turn off the systems, those entities will stay in place and nothing bad will happen to them. I mean, that's what you can look at. You have the process view, which is more of a runtime view. The system runs, it is sending messages, it is raising events, it is calling methods and RPCs and everything. It is kind of data is being exchanged from one place to another, and that is a different view of the same system, right? So that is or you can say, look at it as a runtime view of the system, which is different. Then you have the development view, which is how the software development team organizes its code. Conventions, folders, and the purpose is that I have this class diagrams, how do I map it to my source files, right? If I know that is what is changing, then I can map it back to, okay, this is the view that is changing. And if I have my process view and my development view or my deployment packages, so those are the things that you want to be able to relate to each other. But that's a different view of the system. And then you have the physical view, which is how you actually deploy it to your system, right, in terms of servers and network devices and connections and storage units and all of that, right? Which ones of them are behind a web farm, which of them are scalable, which of them are single points of failure. So those are all the physical views that you want. PCI compliance, you need to describe that these part of the systems are inside the PCI boundary and these are external, and how are they being segregated. So those are all physical aspects of the thing that you need to look. And no one diagram will capture all of these. I've seen people try to put all of them into one diagram, and kind of it gets really messy. And I call it worn diagrams. Write once, read none. The person who's authoring the diagram, he knows everything, but no one else can understand it. And after some time, it just gets falls behind, and there's not much value. It becomes just too complex to maintain, and it changes too much, right? Every time a physical server changes, you don't want to change your diagram. It's only one part of your system that is changing. You don't need to change everything else. The +1 is where the architect looks at, this is what I talked about, the architecturally significant use cases or scenarios. These are the scenarios which says that these are so important that they affect the decisions made on all of those 4 things. This is why we need these particular classes, and why we need these kind of processes running independently, and why we need these types of servers over here and not other kinds. Or why certain processes can live on the same server without any interruption, and why other processes must live on dedicated servers and maybe a web farm of servers and load balance servers, and for whatever reasons, right? Because there is some particular scenario that needs to be addressed, and this scenario kind of captures why the decision is made in the rest of the diagrams. Make sense? Yeah. So most of those views, yes, in theory, or maybe even in practice, you can combine some of the diagrams together. For example, if you have just singletons, one process mapped to one server to one class, yeah, makes sense. Probably you can just combine all of them into one and represent it. But the thing is, it's a good architect who knows where to break the rules and where not to, or where he's not following the rules or where he's breaking the rules. Ultimately, it's all about communicating it and following some best practices and consistency across all of his diagrams. If he's not consistent from diagram to diagram in how he's capturing the system, I mean, he is failing to communicate the impact of the system. And then from the QA point of view and even from the dev's point of view, you don't realize what is changing and what is impactful from when systems are being modified. So in terms of potential gaps, I mean, if you look at any diagram at the end of it, if you just look abstractedly, they're just boxes and lines, right? Take away all the essence, they're just boxes and lines, and you want to make sure that those boxes are consistent across, and you use consistent shapes to represent certain things, and you use consistent lines to represent things. Like if I have a line between two objects, what does it mean? Is it A calling B? Is it data flowing from A to B? Is it an event being raised from A to B? It can mean anything, right? And UML tries to address some of this and follow some fairly syntactically correct kind of representations, which say that if you want this, use this notation. For example, if you want the inheritance relationship, then use this arrowhead and this kind of a line. But if it is a process call, then use this kind of a notation, right? But you want to make sure that the diagrams are consistent in meaning, so that when you look across different diagrams, you're not getting misled, or and you're not kind of combining a class diagram with a runtime diagram, because the notations are similar, but it can get pretty confusing then if you're trying to understand the diagram. Flow is also an interesting thing, and I think my personal thing is I think it's a bit of an art form rather than any science behind it, but my opinion is, and we can debate, and I'd like to hear your opinions also, but I think diagrams has to fit onto one page, and you may need many pages to convey the entire thing, but if it does not fit into one page, or does not fit into, the diagram does not fit into one monitor and is still readable, then the architect has not done a good enough job to kind of combine certain elements or kind of make logical separations and say, look, you can look at this part in isolation and these things are not so important, just as long as these errors. I mean, there is that thing there. I mean, some of the diagrams are big, right? I mean, you have systems with more than 300, 400 tables, and trying to put a class diagram, obviously it won't fit. But there is, then architect can distill and say that, okay, these are all the customer object relationship. And if I just call this as a customer, even though behind the scene there are about 40 tables that capture the customer, it doesn't matter unless you're really diving deep into customer. But the customer can, that particular object can relate to other objects, and so at a very high level you can get a grasp of what the system is. And then when you want to dive deeper, you're just going into one particular area. Right? And so there is a flow of how that information is actually presented. I've seen data flow diagrams where it's kind of going all over the place. There is no start and end, well-defined start and a well-defined end, somewhere lost in the pages, and you have to really try to read hard. Where do I start, right? I have this data here. I have this file that the system is supposed to take as input, and there's a whole load of things, and then spit it out somewhere. Where is it in the diagram that kind of relates to that, right? And if you don't have that flow correctly, then you're just going to struggle trying to figure out what's going on there. And I think the biggest gap I see many failings is the terms and the names and the nouns used in the diagram do not correspond to your software code artifacts, as well as to things that are used in your like servers or inside your monitoring systems. So you're talking about a customer object, and your database tables have a completely different name for it. And now you don't understand, the diagram says one thing, what does my actual representation say something else? And the diagram says I have this server name called this, and your physical server, because of some naming convention, is called server ABC 123. Completely, there is no rhyme or reason what is this server hold and this thing. And that's where things break down, right? It's all about failure to communicate. You want consistency right from concepts captured in your diagrams to your physical implementation of servers and things. And there are ways to do that, and sometimes it requires breaking through boundaries, but I think Sean knows quite a few, past and even in my current organization where the IT have their own server naming convention with a hard and rigid to it, but I have no idea what's running on them. And servers come and go, they break down, it gets replaced, and it deploys something else. Now my diagram is outdated because I cannot map that this process that I'm talking about that I need to change. I don't know where in the server it is kind of deployed. I have to actually look at my code or look at my deployment or my deployment tools to figure out where it is actually going and seeing how to deploy the new versions. Right? Does it make sense in sense of, sure?
Actually, I was thinking there are so many things that an architect is doing on its own way, like whatever it thinks about the product and how the solution should be like that. But is there a way we can test those things as well, we can plan about testing at that moment, what would be the physical state of our application would be and what would be the testing state for those, especially the non-functional requirements that we were discussing before. Is there any input from the architect's point of view for those?
Definitely there will always be situations that the architects can talk about testing, but some of it I think it takes really specialized skills that are required. I mean, test automation is probably that I think many of you can relate to, right? In sense of how do I make these things testable? That means defining interfaces upfront, right? And then you want to make sure that the interface that I've defined upfront actually translate into something visible on the code, either through whatever self-documenting APIs or whatever, right? They have to be consistent. That way, then you can build your test harnesses in parallel while the code is being built up, right? Other things would be very almost like a checklist because they're very subjective, they're hard to measure. So it'll just be almost like a checklist of things that you have to verify. Conventions are a good thing to establish where you say that the team is following this convention to capture the concepts to the implementation, and if the conventions are breaking, is it because of ignorance or because, well, we need to update the convention because something new has come up, right? And even for checking the convention doesn't seem a very kind of value-driven thing, but in terms of efficiency and reducing the disconnects between teams debating about what is the change and how to fix it, that is value there, right? Even though it's not tangible value in terms of code, but just getting everyone on the same page and making sure everyone's talking about the same thing, that itself is a tremendous value.
And is there anything an architect directly talks to testing team people or something like that, like maybe the testing lead or somebody like that, to tell him about what exactly should be the testing framework for this product, should be what areas to be automated, what needs to be unit tested, and what needs to be black box testing or something like that. And anything direct communication between each.
Yes, there should be. I mean, it's all.
There's a couple of opportunities, like when you're saying the cross-functional, I like that by the way, the cross-functional requirements, there's an opportunity there for direct one-to-one mapping with use cases. Right, to say, here, we've got a cross-functional requirement for performance. Excellent. I can write a half dozen user acceptance criteria that really should come straight out of the architect's mouth. I mean, the system has to do these things in order to be architecturally sound, right? So we can get some mapping of that. I don't know that it's, or at least I haven't been in an organization where the architect is saying these things are mandated to be tested by automation, these by black box. I think that's more of a communication between the test leads and the architects to identify the areas that are going to be more susceptible to automation or better, where we're going to get better use out of it rather than other ones.
And some
we're just trying to find the relationship between the product architecture and the testing overall. I see a gap between both. That's what I was thinking. Maybe we need to figure out
But I get that a close
exactly.
relation
a little bit more, you can say, strengthened application can be built on, and more concrete information can be provided away upfront to the testing, right? So that they can plan, they can
Yeah.
move on.
So it depends on the phase of the project, right, as things evolve. So the initial phases, it's all being communicated through diagrams, and definitely what you're working with is different than in the middle and the later phases where you have some solid thing to work on. And that really represents the reality, and that's really what the customer is paying and the features that you're delivering, right? I mean, diagrams all said and done are not working software, so definitely that's not your source of truth. I mean, it helps you understand, but that's not what needs to be tested. But yes, having an early insight into it definitely defines a test plan and test strategy, and that's really where the value comes in. So I think I'm going a little bit over time. UML is a standard notation. I think does a lot of things, right? It's a standard for visualizing systems. It also has its own organization, similar to the 4+1 views of different types of diagrams, but it's used to visualize and specify the architecture of a system. And some of the better tools can even construct or at least establish your base classes and your base packages that you can start using, and also generate documentation for your systems. So it's a bit more of a language to specify it, as well as tools that can consistently use it and help kind of do all of these things for you. So model is the repository which contains all of the artifacts of the system, and you need views to capture kind of portions of the model, right? The model is the entire system, but it's too hard to see in one unified view. So you need different types of views to see how the system interacts with each other. You have these static views which correspond to the logical views over there, which you talk about use case diagrams, class diagrams, component diagrams, and these are there to help define, okay, what are the systems, what are their properties. Go ahead.
Sorry, I don't want to interrupt you.
Oh, it's okay.
I think we're going into design and architecture.
Yes. This is, you're right, this is at the design level. Class diagrams are definitely at the design level, but UML allows you to group a series of classes into systems and subsystems also, which is where you would talk about this thing. And that's where you have component diagrams. We have sequence diagrams, which just talks about how different components interact with each other and what is the flow and how a certain use case touches every system and how they all participate in a particular transaction or a particular behavior. State chart diagrams, I think a lot of QA people would be using, especially to find different types of conditions. So if a system or an entity is in different states, what are the different types of test cases that have to be run? And if someone is changing some particular aspect of the system and just talks about one state, I think this is a good way to say that, okay, but the entity goes through all of these states. What should the system do when this entity in this particular state? Because that is often a missed requirement, and I've seen many situations where the states are infrequent or occur such low frequency that people just get surprised by it. Oh, I didn't know this could happen. And then I think everyone gets surprised by that. But having that in place kind of at least helps you prepare for those things. I think the key takeaway from this is there's no one diagram that represents the architecture of the system. So if anyone comes to you and they say this sheet of paper represents the architecture diagram, I think you can challenge it. And if we have too many different concerns or constructs in one diagram, I think that can also be challenged and say that there is a different way to partition the diagram into different things so that you're just focusing on one aspect of the system. Yes, definitely that means you have to draw more diagrams, but from a learning and a communication points of view, I think that is useful. So an architect has a tough job. Besides just navigating the enterprise skills and strengths, he does have to make kind of suboptimal decisions with incomplete information. very often, literally, many architects just gives a requirements document, and from that they have to figure out what is the cost, how much will it cost, what is the plan, when will I get this thing ready, how much money do I have to spend on it, right? And yes, you can shift to a model of saying that yes, we will commit so much budget and try to deliver so many features and the agile way. But at some point, the product managers wants to know how much is it going to cost me. I want the full product. How much is it going to cost me, right? And especially those in the middle of the road thing where it's not too cheap and not too expensive, right? It's where there is some room to play in the numbers there. The other challenge that the architects have is also communicating the whys. Why a certain thing was made, and if you talked about the architecturally significant use case, that is some reasons to say, that is a reason to say why this decision was made. So I think that's also a key thing of communicating that. Many architects also face this challenge of, I don't know, but I want to try it out, and let's try this out. And then, of course, it's a tentative decision. So I don't want to put it on paper, but I still need to put a plan on it. But at some point, it becomes reality, and then you have to update your whiteboard diagram and say, okay, this is what we learned from the system, and hence things. So there is that little bit of rework that needs to be done. So how in one diagram can you convey, or in one document you can convey that, okay, these sections are current and accurate and they are usable. These are complete, but these are accurate, so it does represent what is implemented, but it's incomplete. There is few things that needs to be added, and I correct it, it's usable. And things that are just tentative, I do not know. It might change, right? And those are the things that have to be communicated in all the diagrams or the artifacts that he produces, and that's a challenge. But ultimately, his strength comes in maintaining conceptual integrity. Any complex system takes time to evolve, and you want to make sure that all the terms, the concepts that are being using, the language that is kind of consistent from over a period of months, right? It doesn't change, and teams have the habit of picking up and getting their own terminology. You have to make sure that it is consistent and is not breaking the initial assumptions or the initial terms that are being used. So I'll skip this a little bit. I think this might be more interesting. So I think kind of recognizing where the architect as a service provider, and it's kind of modified quite a bit as from one of the IEEE papers there, but there's one mode of where the client asks, hey, I want to build this feature, and the architect says, sure, let's build it, and start implementing it right away, and then discover problems as we go along, fix problems as we go along. So it's almost like an architect that emerges organically, right, rather than having a plan. And the other one is saying, no, you don't need it. No, you don't need it. The system can't handle it, so let's not do it. And somewhere in the balance, it says that, yes, it can handle it, but these are all the impacts, and how do you want to handle those impacts, and kind of partner with the client, right? Feedback. Sometimes you can ask the client for the design, and I often see clients proposing designs. Hey, why don't you do this, and it'll solve my problem? And on the face of it, looks good. Dig a little bit deeper, and there's a whole minefield of things that will happen. And that's one thing that's happening right now in my company. A very simple request got translated into a 2.5 month of effort that needs to be put in. But they don't understand the implications of their ask, right? And you have the other end where an architect just swoops in from the thing and says, helicoptering kind of a parent swoops in, here, do this design, and then goes out and leaves the team completely disorganized and trying to figure out what just happened. Change management, in terms of a good one would be about kind of has a strategic plan of how to change the architecture. A too strong one will say, no, architecture should not change, this is it and nothing else is allowed. And a weak one will just kind of go just literally fly by the seat of his pants. So in terms of architecture and agile, I think there are practices that can be learned from each other. from Agile, where it's more of iterative sprints, I think using the architecture to define how to scale up, how to partition work, how to communicate. Definitely, I'm not saying it's about doing the big design upfront thing, but at some point you do need to communicate what is the long term, the quarterly sprint, objective that we want to achieve that will take a few sprints to get there, right? And architecture, how to use agile practices is use iterations to time box things. So I have a long running change to make. Okay, how do I make it into smaller? How do I time box it, and how do I get the experiment and then have time to inspect and adapt and then go on? You can do those things, and architecture should follow those practices also. And then technical debt and refactoring. How do I kind of draw out the business value and communicate this is an important thing that must be done, right? It cannot be always feature every time, and we don't pay anything else to the thing. I'm like, okay, fine, but then talk back in the business terms. Okay, you're talking in terms of story point. This refactoring has this story point, has this value, in either in dollars or in savings, whatever. So, and then that needs to be communicated, and you can do that, right? So that's how we can solve the technical debt problem and get strategic things in place without just focusing solely on features. So a lot of references. So there is a good book called Documenting Software Architectures, Views and Beyond. It talks about the different types of diagrams that you need and what diagram you need to use to convey a certain concept and what it is not good at, which I think is sometimes useful. The 4+1 view model of software architecture is a paper written by Philip Cruikshank. Philip Cruikshank presented a slide on agility and architecture. I think it was an Optimus, this thing, right? Yeah.
Video of Philip Cruikshank. We invited him last year at our breakfast series. So it's online at optimusqa.com/videos.
Yeah.
So if you need the link,
And he talks a little bit about how to solve for technical debt and what are some of the ways to kind of calculate the value of kind of fixing a technical debt. So it's pretty good. I think he kind of talks a bit of how to agile practices and architecture in the same thing. And you have the domain-driven design, which talks about ubiquitous language and saying that, okay, we have an existing system in place. How do I make changes to an existing system without kind of literally causing a lot of side effects, or saying that, okay, I need to refactor the whole thing again because that's the only way I can understand the system. All right. So lots of thanks to Mobify for providing this space. It's good. I think it should be free, and that's always a good, and all of the snacks there. Thanks to them. Thank you and Rupmeet for persuading me to do this talk. I hope this was useful and you had a good discussion, and for all of you for taking the time out of your long days and coming here and listening to me speak. Thank you.
Any final questions for Dinesh?
What are your thoughts? Have you come across these sort of new concepts of like microservices and stuff like that, where architecture starts to, because of the computational speed that's available, storage, memory, where there's a trade-off now where you don't have to architect as much.
Mm-hmm.
Have you got any thoughts on that, or where architecture is kind of going in that regard?
Not microservices as such, but definitely the platform as a service might relate to that, where you're talking of more higher level abstract things, right? You're talking like in the Azure, you're talking of worker roles and web roles, and you're not talking about websites and how many IaaS farms you need and talk physical things. So you build a certain process, and then you deploy it to the cloud, and then it auto scales and it automatically goes up and go down. You don't need to write code to handle all of that. But those are all architectural concerns, right? Where like companies like Best Buy and say, well, Boxing Day I have 10 times the peak load and I need to build for that. And how do I do that? That's an architecturally significant use case, right? How do I handle a load which is 10 times higher on one day and almost negligible on other days? So probably as platform as a service kind of handles those situations where a lot of things is already taken care of for you. And I don't know, maybe is that what you're thinking
Yeah,
of?
so is the future of the architect in that regard then how to make use of those pre-built things in a proper manner
Right.
for your business case or your business market?
Yeah. So in which case then I think the architects would be is what is unique to my business which sells their value effectively, whereas which is just either tax or just need for my efficiency. Like in terms of an organization, every organization needs a payroll. Do I need to build a payroll system? No, you just go to ADP. Yes, you're paying some money, but that's not your core competency, right? Your Mopify solution is to build solutions, and they don't need to take their developers to build a payroll system. We just outsource it. And similarly for in terms of logging infrastructure, in terms of data mining, we just outsource all of those because the solutions are routine. They're not specific to how you deliver. For example, in our company, AutoTrader, where we actually I don't. Anyway, so I work in a company which we operate the website autotrader.ca, which is all about buying and selling used cars, right? And yes, we do need to do logging of whatever operations are there, and that's something we don't need to write custom code to handle that. Tools like Logstash and Splunk do the job effectively, right? We need to scale our solutions. I mean, if you see our utilization charts, it's all high during the day, a little bit in the evening, and midnight and all, we have 0 CPU. We don't need to build over capacity for those things. It just goes to the cloud and just outsource the capacity planning and the cost directly off to the cloud services. And we have many other tools that you just literally rent it out, pay by the hour, and you don't need to solve for those problems. And you get a lot of insights and valuable tools from that.
Kind of like the same thing when we were talking about databases. The architect's job is to say, here's the problem we're going to have at this time we need to scale up. Make a technology decision on what you want to do to accomplish it. But here's the parameters that are required for it. So I mean, the architect's job then is to identify the problem space and maybe suggest technologies that can be used to achieve the result, as opposed to necessarily creating it themselves or setting up a plan for development.
Yeah.
Yeah, that sounds
Right.
All right. Thank you,
Okay.
Dinesh.
All right. That's okay. Oh, thank you. Very nice.